Welcome to a new test and teardown video. This time it's a very old general radio. It's a signal generator. It's called a type 1021 and it consists actually of two units. As you can see, there's a line here, so you can take out this is a plug-in module, the oscillator module. So, and this one is the P1 for a power supply, and then the other one, this one is the P3B, but they exist in at least 3 different models, and this one is the lowest frequency range. So it got 2 ranges, 40 to 50 and 50 to 250. Then the next module is a 250 to 900, and then the other one is 900 to 2 gigahertz actually. So it exists in a few different models. As you can see, this one is the 1950 model. It is very easy to see on this meter. They are very different in the 1960 and 65 models. And it's AM modulation. So the power supply is doing metering, a power level, modulation, and stuff like that. I guess this is actually all it does. It's also calibration for output power, so it's done by anode voltage or anode current or something like that, I guess. I'm going to look a little bit deeper into that. The oscillator is of course mechanical. And the coupler, the output coupler, is this distance coupler into the field, and this kind of coaxial output coupler is very accurate, and it's done by adjusting the base distance and then looking at the meter, and then keep this one where it's supposed to be accurate, and then from here it will be accurate. Push to calibrate. What am I calibrating here? I don't know exactly what's going on here. I think this is an adapter that is kind of glued, screwed, or mounted in some way, because it's normally a very different output connector, but now it's modified for a BNC, so that is good. I can't take this out, so maybe we should try and open this first before I power it up, because I can see here this corner is a little bit bent. I don't know if that is easy to see. So somebody threw this in the trash can and somebody else saved it for later, so I don't know if it's gonna blow up or if we got broken tubes or something. I don't hear anything rattling, so let's see. We could just power it up and see what happens. What is the worst that can happen? Okay, we're just going to power it up. So first we hit mains, and so far nothing bad happened. 50, 45, 30 watts, 20, 35. It goes a little bit up and down, and we are looking here at the output at the same time. So where are we going to get a lot? This is millivolts, microvolts. Okay, it needs to be that way. And then what have we got here? Calibrate, la la la. It's 35 watts, and the meter, that is modulation. Oops, look at that. It's definitely oh, look at that. So when I poke around with the modulation button, I can actually activate the output. So something is working, but look at that. Nothing in carrier. What do I do with this? And then modulation, I just have full hammer here. Yeah. This tells me something is not so good. So let's try the... Holy camole! That's the other output. And then, okay, carrier. And we're supposed to adjust this. Yeah. Ha ha! Okay. So that output seems to be good. Look at that. We got 112 megahertz, and that's probably what we got. Let's just put it here so it's easier. So this is 120. I mean, this is 121. And this thing is from 1950. Are you kidding me? Okay, that is great. So I'm happy about that. So that is external, because this is modulation. I don't understand this. Okay, there's definitely some... See, modulation is not working. But see, there is something going on. That means the modulation is actually coupling to the output kind of thing, right? But the oscillator, the modulation oscillator is not working. And this output, oh, holy, so that output is not working. Oh, so that is the other output. La 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 la. Oh, and then it goes off. Okay. Anyway, that is 300 megahertz right now. But see, we got some modifications done to this. So this band, somebody's been writing some other kind of stuff here. But I mean, this is a little bit weird. It says 170, but I get 281. I mean, really? And it looks nice. So that is some, and then it goes back. Okay, so 50. Okay, so it goes in some other mode, this oscillator. So here we go, 46 megahertz, and then see, and 45 and 60. Okay, so it's been modified, the frequency ranges, and that seems to be working quite all right. And then we kind of go over the range, and then oops, it's not working anymore, and then it goes in an uncontrolled resonant mode, able to do quite a lot of 300 and some megahertz. Wow, this unit was not supposed to be able to do that. 330 megahertz. I mean, we need to open this thing and figure out what is wrong with this modulator. Now that was easy. We got this big round resonator unit. I guess there's only one tube in here. Oh, look at that. Some screws here, and then we can take off the... And then there's a connector. What? Yeah, okay. So that's fairly easy. So I took out the power supply, and I've actually been sitting here playing a little bit with bug finding. Let me show you the power supply. And this one is heavily modified, by the way. See, there's another little transformer down here, and this is for filament. So a low voltage, a DC regulated filament for the oscillator tube, and there's a nice little regulator here. So So that is a nice mod, and those two tubes are of course not needed, and because one of them was an AC, well, in the original design, the oscillator tube was running on AC filament, and then there was a series constant current regulator tube mounted here, and that is of course not needed when it is regulated DC. And then there was a rectifier tube for high voltage, and that has just been replaced by those two tiny diodes. And I took out the oscillator tube, the modulation oscillator tube, because this circuit is not working, so I'm debugging around in this circuit. It's a little bit annoying, but I can't power up the power supply without having the oscillator connected. And those guys actually made a little trick here. So AC mains is going out and then back again. It's shorted. I don't know if we can see this, the two top pins. So if this connector is disconnected, that means there's no voltage on anything here. Just a classic idiot proofing kind of method. Other than that, yeah. This is the big inductor for filtering, and that is the mains transformer. Yeah, the meter and the two adjustments. Super good quality pots. So that looks promising. That will be the two voltage regulator tubes. They're connected in series. They're 120 volt each. So we're running on 240 volts regulated high voltage. And what else can I say about that? Yeah, we got some leaky capacitors, and all those capacitors here, they're in the oscillator circuit. So and this capacitor here is in the anode supply of the oscillator, and then there's the resistors and stuff like that for the meter. Remember when I went into modulation, then the meter just hammered out all the way, and of course the oscillator is not running, but I got full meter. And this meter was only supposed to show AC of the oscillator circuit, so that I already knew that this capacitor had a lot of leakage current, and that leakage current goes just straight to hammer out the meter. So of course, without this mounted, I got no meter readout, so that was definitely the problem. And the other capacitors, they're definitely going to have the same problem. Let's look at this capacitor. I don't know if you can see this, but this is not, because it was in the rain. So we got some crappy acids, and I bet the others, they're just as wet. You can even see the metal looks a little bit leaky. I mean, I just need to replace all of those. So now I changed all the leaky capacitors. That type is just absolutely bad. All of them got this kind of... Let's have a look. Okay, one of them is... Let's see the other end. No, this is nice and dry. But the others, they are wet and gross. So I changed them, and there are, what are they? Yeah, 150, yeah. So this is what I got. I didn't have enough of the same type, but it doesn't matter exactly what type it is. I only got about 300 volts in this area anyway, so it's fine to use 400 volts capacitors. They used 600 volts just to be sure, I guess, or this is what they had. The size and the length is absolutely fine. So let's power up and let's have a little look how it looks like. And this is our RF output, and we are in a carrier, and this is the calibrate carrier. Yes, that still works. Then we go to modulation, and now there is no that's me being silly. Of course, we need to go to the internal oscillator, and then we should be able to crank up there. And if you look here, this should be percent modulation, and look at the scope. So that's 10, 20, 30, 40, 50% modulation. That looks a little bit less than 50%, but on a good day maybe let's crank it up. Yeah, that is better. I mean, half of it, yeah. I mean, the meter maybe is a little bit low. Like that would be 50, right? Okay, so it's repaired. Haha. So now I can put the power supply back, and let's look in the big funny can of goodies. See, it's actually a double cased container system, but let's look at the oscillator unit. It's huge. So here's the frequency adjustment. So there is a variable capacitor, as you can see here, between the two halves of the tube. So this is actually a center fed anode. It goes to the two anodes, and in this point down here, I don't know if it's easy to see, but there's a cross couplings to the two grids of this dual tube, and that is why it's oscillating. And this capacitor is simply choosing or selecting the resonant point. So this line here, down here, is actually the output. This is the attenuator coupling. Let's have a little look. And here's the output coupler. The closer it goes, the more output you get. It is that simple. You see there's a little coil in here. Yeah, so that is how it works. And let's see if I can show you. Yes, I can show you I can actually show you the two couplings to the two grids. Here we go. That is one of them. And there's another one on the other side. Oh yeah, this is the band switch. See if here's the knob for the two bands. It goes in here, and then it's connected to that arm. So those two capacitors, they go in parallel with the entire circuit, and this way moves the entire trim area, yeah, to a new range. So that is how that works. The output here, I need to be careful now. So this is the output via this coax, and it goes into this system here. I pulled it apart because in here there's actually a crystal diode. So this is a very, very special diode. So here's a DC voltage, and in this unit you can see here is actually the bottom part of a disc capacitor, and here's the top part of another disc capacitor, and in this part there's a coil in the middle, and this coil is soldered to both ends. So that means if I unscrew this part to go in here and show you the inductor, I will ruin this part. So I will not do that, of course. I'll just mount this again here in a second. But I want to show you this really, really nice old connector type. See, this is a unisex connector. Isn't that funny? So there is only one connector type, and it just fits the same type of connector. It's just made. This is a genius design. So the inner conductor works exactly the same as the outer. I mean, that is a very nice RF connector actually. I kind of like it. And of course here is an adapter that is mounted, and it's actually screwed so tight so I can't get it out. And then it's made for BNC. Probably just screwed on real tight and then soldered here, so there's no way I can get this out. Or maybe I could just desolder it and then I can unscrew it, but it's exactly the same, right? So no need to poke around with that. So yeah, that is the entire oscillator circuit. And that was the band switch with the little click spring. We only got two wires going in here, and that is filament and anode voltage. Filament is a DC voltage that goes directly to chassis, and then the anode voltage. That is all you need. As you can see, they just used all the space they got. And here's one inductor, and in here more capacitors and inductors, and on the top again more filtration. So they really meant serious business when they did the filtration here. This spring is actually what pushes this scale towards this dial. So here's a shaft that touches the edge of this one, and this creates the gearing. And that's how simple it is. Yeah. Here is the schematic. This tube is a constant current tube. It is of course removed. Point C is the filament for the oscillator tube. So in my unit this has been replaced with another transformer and a regulated 6.5 volt supply. Also in this unit the high voltage rectifier tube has been removed and replaced by two silicium diodes. The high voltage goes through this those will be high voltage regulators, and there's always a short in the sockets, so that means you take the anode voltage through each socket like this. So if you remove the tube, you don't have the high voltage regulation, but you don't have high voltage left. So that is why it is safe to remove them for debugging and something like that. You just unplug one of them and then you have no more high voltage. So this is a classic implementation of high voltage regulator tubes. So that was the oscillator tube that was not working, or of course the tube was working, but I had a lot of leak in all those capacitors. So I replaced all the leaky capacitors, and that one, and I also replaced this. Yeah, I replaced all the leaky capacitors here, and then oscillator is working, and I got modulation, and that was the capacitor I was I was talking about that hammered my meter to maximum because of leak, and the rest of them just stopped the oscillator. The short circuit between A and B, as you see here, that is a mains voltage that goes through the connector to the other unit. And of course, if you unplug the connector, there's nothing going on, and you don't have high voltage or anything bad in the connector, and this is good for safety. And this is the manual, and it shows how the power supply would look in its original glory before any kind of modifications. There's also a very good picture that shows the placement of all the different capacitors and stuff like that. So it's really a good manual, and it really helped me a lot debugging this. The manual also covers the two released units at the time the manual was released. So that is only the UHF unit that goes to 900 megahertz. It looks like this. But I don't have this unit, so it's not that interesting for us to look at. I just wanted to show it as well. This is the oscillator unit I got, and it covers 40 to 50 or 50 to 250, depending on the band switch. Let's try and zoom in a little bit down here. So I think the manual is really good to explain how stuff works. So this is the band switch and the oscillator, the variable frequency adjustment, and here is the attenuator pickup loop, and here is the crystal rectifier, and that is the magic patent. It's just a disc capacitor and an inductor and another disc in a sealed unit in a nice sexy cylinder. And this is of course in the power supply module with the meter. Here we can see everything a little bit better explained. Just for here we see the two filters, the first filters, and then inside we had another inductor, and again another inductor on the top to the sensor feed point. And I also explained about the two capacitors in this cross. So this circuit looks very much like an astable multivibrator actually. If you look closer at it, you got the resonant part between the two anodes, and see the cross to the two grids. So yeah, that is what it is really.